Hello. All right, so yesterday, and this video is going to count for day 3 stuff, we were talking about factoring by grouping. So we were taking these long string of things, we were creating groups, and then we were factoring each of those groups to get down to a fully factored form, much like this one. Today we're going to be using the same technique, which is why this video is going to count for day 3's video as well, in order to solve the equation. So once we're done doing this stuff, we'll have this, let's zoom, focus, we'll have that equal 0, that then we can apply our zero product property to and have this first thing equal to 0, the second thing equal to 0, which then are much easier to solve. Okay? And our final answers in this section will be in the form of x equals some number, which may or may not be a real number. We'll have to see. Which one of these do you want to start off with? Which one you want to do? All of them. I'll do at least 2. I'm happy to do as many as 4, but I don't want to do too many more than 4. Front or back?
2.
Number 2. Okay, we'll do number 2. And then one of the shorter looking ones.
6.
Number 6. I heard 15? 16. Okay, let's do number 15 and see if that answers your, or excuse me, we'll do number 6 and see if that answers your question. If it doesn't, then we'll do 16 happily. Okay, so let's do number 2 first. How many terms do I have? 4. I got 4 terms. Don't forget to add, like, count the one at the very front, and don't forget to count the one that doesn't have any x's. So we have 4 terms. If I look at these 4 things, I don't have a common factor between all 4 of them, and so I'm going to go immediately into factoring by grouping. Step 1 to factor by grouping, create some groups. Groups created. Easiest step ever. Now that our groups are created, I get to select what goes in each group, and I can select as many things as I want in each group. I recommend that you consider putting, don't put all 4 things in one group, because then we would have not done anything. Okay, so put some stuff in groups. Tell me, what do you want in the first group?
2x cubed.
Okay, 2x cubed. And minus x squared. Okay, and that forces my other group to be 2x minus 1. All right, now that I have this, I'm going to factor by the greatest common factor. So I am going to write down the factors of each one of these things. This is 2 times x times x times x. Now this one, I want to handle that negative in there, and I'm going to do that by adding in a factor of -1. So I'm going to turn that negative into a -1 as a factor. All right, now I'm going to circle things that they have in common. They have an x in common. They have another x in common. That's it. They have an x squared in common. So I'm going to write down that common factor, and then parentheses, I'm writing the stuff that they don't have in common. In this case, a 2x and a -1. It is the same thing as this other one. Look, it's the same idea. So I know that this is going to drop down this way. The problem is that I have this blank space right here. Now remember, this is a factor, so this is multiplication. What number could I add out there that I could multiply to this group, which won't change it at all?
1.
A 1. So I'm going to throw a 1 right here. And now it's easy for me to see the things that they have in common. And so I'm going to write those down. That's my common factor. And then in parentheses, the stuff they did not have in common. Now that my factoring is done, time to apply the zero product property. That's when I have stuff times stuff equals 0. So I'm going to write the first stuff down and set it equal to 0. I'm going to write the second stuff down and set it equal to 0. And I'm going to solve each one of those equations for x, which should feel, hopefully now, fairly simple. The one on the left, I'm gonna add 1 to both sides and then divide by 2. The one on the right looks a little more tricky because I have an x squared. But I have an x squared plus or minus some stuff. So I'm gonna get rid of the plus or minus some stuff to leave the thing squared by itself. What squared gives me negative 1? Okay, yeah, not 1, because 1 squared is positive 1, and not negative 1 either, because negative 1 times negative 1 is positive 1. This was our, yeah, and there's no real number that does this, so this was our imaginary number. X equals I. Because the property we assign to this little letter I, the imaginary number symbol, is that when I square it, it spits out a negative 1. Okay? Easy enough? Maybe this part was the trickiest, yes? But everything else was okay? Alright, I'm happy if you can get down to something that looks a little bit like this. Okay? You're going to try to go as far to that as you can. Okay? There's probably going to be some I's that happen. Alright, let's look at number 6. Number 6 is going to require us to have out our notes from day 1 because this thing looks suspiciously a lot like one of these. Which one of these does number 6 look like? Which one of these does number 6 look the most like? This one? This one, because there's a plus sign in the middle. Okay, so it's likely a sum of cubes. So I'm going to hang on to this paper here off to my left because I still have a hard time remembering the factoring. And what I'm going to look for is I'm going to look for, does this thing in fact, is it able to be written as stuff cubed plus stuff cubed? All right, let's look at the last one, the 8, because there's not a lot going on with the 8. What do I need to multiply to itself 3 times to give me 8? 2. All right, so in here is a 2. What do I need to multiply to itself to give me a negative 27? Negative 3? Positive 3?
Negative 3.
It has to be a negative. Okay, so let's try negative 3. Negative 3 times negative 3 is? 9, positive 9. Positive 9 times negative 3 is? There it is. So we've got a negative 3 here, and then we have that x so that we can get the x cubed. We now have stuff cubed plus stuff cubed. And whenever we have that happen, I can use my little cheat sheet that's here off to the side. And I'm going to write. My pattern says the first thing plus the second thing, then in parentheses, the first thing squared minus the 2 things multiplied together plus the second thing squared. It is, but not hard. Right? Just a lot of record keeping track of stuff. Alright, going to clean up a little bit. I don't need to do anything to the first group of parentheses, but to the second I do need to do a little bit of cleanup. Okay, let me know if you're not sure where I got any of those numbers. All right, I had thumbs up from everyone. Now I have stuff times stuff equals 0. So I'm going to use my 0 product property and have the first thing equal to 0 and then the second thing equal to 0. So this thing equal to 0. And then this, you know what, I should probably stop calling them things, right? Because they have a proper name. They're factors. So the first factor equals 0, the second factor equals 0. where factor is just a fancy way of saying stuff that you multiply. Alright, I can solve the first factors equation. That one's fairly simple. Gonna subtract 2 from both sides and then divide through by -3. And when I'm done, I have that as a solution. Next up, the quadratic. And I can't factor it. So don't go 9 times 4, 36, factor pairs of 36 that when I add give me positive. It's not going to happen. You don't even have to bother wasting some time on that, because whenever you use sum or difference of squares, this quadratic that gets spat out at you, it doesn't factor. So we can automatically rule out factoring as a tool that we can use, which leaves us with either completing the square or the quadratic formula. To complete the square, this first leading coefficient needs to be a 1. And if it's not a 1, you have to make it be a 1. Which means I have to divide everything through by 9. Think about that for a second. How many fractions is that going to create for you? A lot. And then you know you're going to have to take that fraction, divide it by 2. Let's see, more fractions. And then you're going to have to square that fraction. Yeah, right? Most of you are shaking your heads and having a panic attack. So while you could do it with completing the square, it might be challenging. So set that one aside as a, only if I have to. And let's try the quadratic formula. Quadratic formula was my little song. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Where this number is a, this number is b, this number is c, and you ignore the x variables. Just grab just the numbers. Alright, here I go. Do, 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 do. Whoops. Yes, but it looks like a mess, so we're going to clean it up. Okay, so we're going to square things, we're going to multiply stuff, then we're going to start trying to add or subtract, and then see if we can take square roots of things, and then maybe divide or simplify whatever fraction we see. We're just going to keep going till we run out of stuff to do, and then we're going to stop and call it a answer. You have a thinking face. Ask me your question. It's okay. I like thinking faces. Keep thinking till you find it. It's okay. It's all right. It's okay to be like, I don't know what my question is.
36.
Yeah, it's a 36. I did 6 times 6 for 36, and now I'm stuck on 4 times 9 times 4.
Yeah, I was gonna ask that. Are you gonna multiply them all?
We are.
Together?
What was it again?
144.
144. Yeah, these 3 get multiplied together.
And then the 20. Oh no, that's a 2.
It's a 2 times 9, which is 18. $36 minus 144 is negative 108. Oh, thank you. I would have gotten there eventually. All over 18. Now, I see a negative, which automatically triggers the knee-jerk reaction of, I'm going into imaginary numbers. I'm out of space, so I'm going to grab some line sheets of paper over here, and I'm just going to keep writing. So this is number 6, and I'm going to write here, continued on attached. And then I'm going to rewrite where I've left off so that I have it. Okay, so that's where I left off. I have a negative under a radical. At this point, you should be fairly well training yourself that when you see a negative under a radical, you rewrite it immediately with the letter I sitting outside of the radical. So I'm going to stick an I here, and I'm going to leave a space because I don't know if, maybe I can get something out of the 108. Okay. So I'm gonna start trying to figure out factors of 108. Okay, factors of 108 are,
Twelve.
9 and 12? Okay, 9 and 12. This 9 has a perfect square root, doesn't it? The square root of 3. So that's going to come out of my radical as a 3. Let me check the 12. What are factors of 12? 3 and 4? Yep, and 4 is a perfect square. 2 and 6 are also factors of 12, but 2 and 6 don't automatically give me that perfect square. I'd have to keep going and break the 6 apart. So picking the 3 and the 4 is just a shortcut. 4 has a perfect square root, so it's going to come out as a 2. These are the things that are outside of my radical, and I'm going to multiply them together. 3 times 2 is 6. This is what's left over inside of the radical. So now my fraction looks like that. Can I simplify the fraction? Looking at just the real numbers. Don't look at the i's. Don't look at the things inside the radical. You're looking at just these numbers. I can, in fact, simplify this. When I simplify 6 over 18, I end up with, when I look at 6 over 18, it reduces down to? Yeah, 3, but on the bottom, yes? So 1 over 3. So all the 6's turn into 1's, and all the 18's turns into 3's. So and that's as far as I can go. All of that for that. None of it particularly difficult, yes? I mean, coming up with these numbers can be a little bit of a challenge, but use your phone to or your calculator app on your phone or on your calculators to kind of help you find what things multiply together to give you what other numbers, especially as the numbers get large. Okay? So that's a tricky step, and otherwise, none of these should be really challenging. Questions? Comments, concerns? You had asked to look at 16. So looking back at 16, do you still need to see it, or was the one that we just did enough? It's the same pattern. You don't need to see it anymore. Okay, does anyone else still want to see number 16? Looking around the room. That's a big fat old note. All right, then we'll call it here. Thanks, guys.